Okay, welcome back. It's abrupt earth changes, and this is about droughts in a grand solar minimum, flooding and drought, and the connection to relative humidity. I'm taking this from my article here, The Next Grand Solar Minimum, Cosmic Rays and Earth Changes, an introduction. So we are aware of potential of flooding during a grand solar minimum. Cosmic rays cause cloud nucleation, which can trigger erratic rainfalls. So we know that, but also there is less evaporation due to cloud coverage, and clouds tend to get rained out more violently. So we have flash floods, but in general, more droughts. And the regular transport into the continents is diminished. Now, these droughts are then more prevalent, and needless to say, they can be marketed as global warming. Even there has not been any global warming since 2000, around 2000. Well, this might not even appear that absurd at the beginning, because the early stages of the next grand solar minimum, whenever it really starts, will be quite similar to what the proponents of anthropogenic global warming are promising, minus the earthquakes and volcanoes. So, due to shifting jet stream patterns, we also have heat waves and more wildfires in some regions. The high solar activity leads to high specific humidity in a grand solar maximum. So it's not just warmer, but generally benign weather, more sunny weather. And in the maximum, we have more water vapor in the air, and that's water vapor, not fog or condensated droplets. And water vapor is a greenhouse gas 10 times more effective than CO2. And this way, another feedback mechanism is generated towards warming and more stable weather during a maximum. Then, in addition to the higher humidity and the fair weather, we have a greater difference between day and night temperature, which leads to more dew formation. Everybody knows that in a starry night, in a starry summer night, you have more of a drop, which leads to dew. And this brings us to the point here. So in a solar minimum, we have less specific humidity, and that leads to less dew. And why is this important for agriculture and civilization? So if we have less dew precipitating on grass plants, then that can cause a stealth drought without even having an influence on actual precipitation. So dew is very important for grass plants, and these plants can absorb moisture from the air at night. There are little microscopic dust particles on grass leaves, and some plants have these little hairs. Both serve as condensation nuclei or condensation surfaces at night when temperatures are low and relative humidity is high. So that's how grass is wet in the morning. And then some plants absorb the droplets through the roots or even through the leaves. So grass can grow in relatively dry topsoil and for extended period without the rains, whereas more complex agricultural plants need regular rainfall or irrigation. So we have grass plants that are very important for animal husbandry, of course, also works in prairies. And then we have grass plants as wheat and rye and other cereals. They can function similarly in relatively dry conditions. So, in closing, during a solar minimum, and particularly during a grand solar minimum, local droughts and crop failure may be caused not only by less rain and more winds, but simply by lower specific humidity. And this may not even show up on a climate chart. Usually we measure climate as temperature and precipitation and not the relative humidity. Okay, so that's all for now. The rest is in the article. I haven't heard anyone address this. Not that I'm aware of. I think it's of significance in the context of a future grand solar minimum. Thanks for watching. Bye.